So we want to determine whether x equals to y squared plus 19 is symmetric with respect to the y-axis, the x-axis, the origin, more than one of these, or none of these. So let's go ahead and let's check with the first. Let's look at the y-axis. We're going to replace, and I'll keep repeating this until you learn this, replace x with negative x. So go to the original equation. Here we go. Let's put original. Replace negative x with negative x. And do we have the same equation, identical equation? No. So we can say no, because this first part here, you're saying negative x equals to y squared plus 19, and that's it. It's not the exact same equation. Let's look at symmetric with respect to the x-axis. We replace y with negative y. Here's our original equation. Where we see y, we place negative y there. We have the quantity of negative y squared plus 19. And the quantity of negative y squared is y squared, because you have a negative times a negative, which is positive, y times y, which is y squared. So here's our new equation. Is our new equation exactly the same as the original equation? Yes. So at this moment, I'm going to say yes, it's symmetric with respect. Oops, there we go. To the x-axis. All right, and lastly, the origin. Replace x with negative x and y with negative y. Here's the original equation again. We have negative x is equal to the quantity of negative y squared plus 19. Then we have negative x equals to y squared plus 19. So this is our new equation. Does it look exactly the same as the original? No. So it's not symmetric with respect to the origin. So our answer is that this is respect to the x-axis. Now, I want to show you the graph to this equation. X equals to y squared plus 19. Look at our graph. It's the parabola that opens up to the right, and because it's opening up to the right is, well, because y is being squared, this is why it's opening up to the right. Had the x been squared, then it would have been opening upward. And look at your x-axis. If you fold along the x-axis, the points that we identify above and below the x-axis are going to match. Okay, so we can pick a point here. We can pick some more points. One here, one there, but they're symmetric to the with respect to the x-axis. So that I want you to be able to have a visual as to what this looks like, because you may not have the visual as we're just working the equations, you may not have time to graph it. So at least being able to see what it means with respect to the y-axis, the x-axis, the origin. Let's do another example. We have here x squared plus y squared equals to 16. And let's do each symmetry check. First one, starting with the y-axis. We're going to replace x with negative x. Here's the original equation. Let's substitute. The quantity of negative x squared plus y squared equals to 16. The quantity of negative x squared, that's negative times negative, x times x. So that's going to give us positive x squared plus y squared equals to 16. Does our new equation match the original equation? Yes or no? So I'm going to say yes and just say y-axis. Symmetry or symmetric with respect to the y-axis. The x-axis. Replace y with negative y. X squared plus y squared equals to 16, our original question. So we have x squared plus the quantity of negative y squared equals to 16. Tell me what is the quantity of negative y squared, which will be positive y squared. So now that we've replaced y with negative y, does our new equation match the original? Yes. So it's symmetric with respect to the x-axis. Last check. Symmetric with respect to the origin. Replace x with negative x and y with negative y. Here's the original equation. And let's replace. Raising both the negative x, the quantity of negative x, and the quantity of negative y to the power of 2 will yield positive values. So we have x squared, that's positive, y squared, that's positive. So our new equation matches or is the same as the original equation. So we would say yes, it's symmetric with respect to the origin. So it's all three. So remember, we talked about different types of graphs. And whenever x is squared, y is squared, we have a circle. So we can fold along the y-axis. We have points that's going to match. We can fold along the x-axis. We have points that's going to match. We can fold at the origin. Okay. If you notice, fold at the origin, then we're going to have points that's going to touch each other. Doesn't it can be positively if we fold at the origin here or negatively. But you still will have points that will match. Here we have the y-axis. Okay. -4 0, positive 4, 0. Symmetric to the x-axis. 0, negative 4, 0, positive 4. Okay, so it's all three when it comes to a circle. So we will say yes, yes, and yes.